Hi, hope everyone is safe at home. So, meanwhile, I started to make a small introduction about the subject of trigonometry, and I hope it might be useful for you when you are referring, or maybe you are going in detail into the concepts, right? So, trigonometry, as the name suggests, so the name can be divided into three parts. So, tri means the three parts of a triangle. We name it, we give individual names to as the opposite, adjacent and hypotenuse. We will discuss what those sides are. Followed by that we have this metry, which is the study of triangles, especially the right angle triangles in the 10th standard, of course. When you enter into your 11th standard, you might be studying the sine formula, cosine formula for the inclined triangles, right? So let us proceed further. So trigonometry is a branch of mathematics which deals with the triangles. So not necessarily the triangles, the angle between the sides of a triangle, right? So you have three sides. We will give some names to them based upon the angle, right? So now you might ask a question. So where does this where do we find daily applications of this? Of course, everywhere, in designing or in analyzing or in order to find out something, you require an excessive knowledge of trigonometry. For studying about calculus, you need a you must be fundamentally sound in trigonometry. So this is the reason why you study trigonometry. And with the correct knowledge, so you can easily design this. But if you don't possess any good knowledge in trigonometry, it would be very difficult for you to analyze or go through the concepts, or maybe in designing components, right? So the next thing is to classification of triangles. So basically, how do you classify a triangle? Is nothing but the right angle triangle. So broadly you can classify this into right angle and the other triangles. So in right angle triangles, the Pythagoras theorem is valid. So we will discuss what is the Pythagoras theorem. And in the other triangles, right, isosceles, scalene, equilateral triangle, wherein which your Pythagoras theorem is, you can't necessarily say that it's valid, but we have to do some resolution. We will discuss what is resolution in the proceeding class, right? So Pythagoras theorem is nothing but, so you have the longer side of a triangle, which is called as the hypotenuse, and then you have two sides. So upon squaring the individual two sides and summing up them, I would get the square of the hypotenuse side. So let us say a person is standing over here, right? So if he moves from C to B and from B to A, he would have to cover a long distance. Whereas if he covers from C to A, that would give him a shorter distance, right? So if you assume A to C as 5, B to C as 3, and A to B as 4, and the sum would give you 7 instead of 5. So which means that the distance is very much larger than your displacement. If you see in the figure, AC is your displacement, whereas C to B and B to A will become your distance, right? So you have to clearly understand this concept. Okay. So now if you look in this figure, you have a right angle triangle. So here comes the main idea of trigonometry. Okay. So trigonometry involves modeling of the real world problems into a mathematical domain, right? So you have to model this. So assume that a person is standing, he is leaning against the wall. Okay. So instead of drawing the entire person, I can just represent it by means of a single line, right? And the other thing is, so you can draw the opposite line as well as the adjacent line, and the angle made by his feet with the ground, you can name it as any angle. Normally we use 10, 20 degree or whatever it is, but in some case, generally mathematics doesn't like us to express it in form of numbers. It likes us to express it in form of unknown variables. So here this symbol is called as theta, where theta stands for the angle, right? And the side which is opposite to this angle theta is called as the opposite side, and the side theta which is adjacent nearer to the side is called as the adjacent, and the side which is opposite to the right angle is called the hypotenuse. So let us say you have an angle over here, and then your opposite side would become this, not this, right? And then your adjacent side would become this, and your hypotenuse would become this, right? So hypotenuse is the side which is opposite to the right angle triangle, right? So this is how you model and you solve some problems based on this, right? And next is the next part, the most important part of trigonometry is the ratios, right? So when you have a triangle, only a maximum of 6 ratios can be obtained from a triangle by dividing the sides. I mean, you have 3 sides, right? So you divide any 2 sides and out comes some beautiful number in the form of angles, right? So here are the 6 important ratios. They are just derived. You can even call cos theta as opposite by hypotenuse. It doesn't matter. The earlier mathematicians gave these numbers, right? So we will follow by their convention. So you have sin theta, which is opposite side by hypotenuse. So opposite side is here, and the hypotenuse side is here. And next you have the cos theta, which is adjacent side by hypotenuse, which is this side upon this side. And next is the tan theta, which is opposite side by adjacent side. So this side upon this, right? So this cos, the full form is called as cosine, and this is tangent. Tangent, you know what's a tangent? It is a line touching a curve at a given only one point, right? And this is cosecant theta, which is inverse of sine. I mean, you can write this 1 by sine theta. So upon doing some simple steps, you will end up with hypotenuse by opposite side. Then you have secant theta, which is hypotenuse by adjacent side, and then cot theta is adjacent by opposite side. So if you compare sine and cosine, you can express it as sine theta is equal to 1 by cosecant theta, where theta is your angle, right? And cos theta is as 1 by secant theta, and tan theta as 1 by cot theta. So these are the 6 trigonometric ratios. So we call this trigonometric ratio because these are corresponding to some angles, right? And you might think, is that it? So does trigonometry come to an end with this? No. You have some applications of this trigonometry. So let us consider, where do you use this trigonometry, right? So let us consider an example. So you have a lighthouse, so which emits signals in the form of light beam, and then a ship is approaching towards the lighthouse, and then if let us say the beam is traveling at this direction, and the angle made by this beam with the horizontal ground is, let us say, this is angle of depression. Depression is where, if you see from the top, and if you are at the top and you are seeing the ship at the bottom, and the angle is called as the angle of depression, right? Whereas if you stand at the ground and if you look at the lighthouse, and the angle made by your eyesight with the horizontal ground is your angle of elevation, right? Those are just name conventions, right? And you know that this angle will always be equal to this angle, because this is an alternating interior angle. So you can equate this. But so if I know this distance, I mean the distance from the lighthouse to this water, the ship, and if I know the height of this, let us say the height of the lamp house, then I can easily determine this distance by applying Pythagoras theorem. In most of the cases, you would never know this distance, the distance from the lighthouse to the ship. So what do you need is just the angle made by the light beam with the horizontal, right, which is called as the angle of depression. So if you know this angle, it will be very easy for you to calculate the angle of depression, right? So you might think that, yeah, so trigonometry has come to an end, we don't need anything apart from this. No, trigonometry has got a billion of applications. It is a gargantuan topic in its own. There is a single book about trigonometry for over 2000 pages. Maybe you can buy it and read it. And next is the trigonometry. The biggest application of trigonometry is the rockets, right? So you have the rocket fins. So they are placed at certain angles so that the air which is interacting with the rocket doesn't get affected, and you have a smooth flow over that. As a result, the rocket would climb up greater heights, right? So trigonometry, excessive knowledge of trigonometry is required in these fields, and in order to study about calculus, it is another particular subject wherein which the rate of change of objects are dealt in excessively. For that, you require a humongous knowledge of trigonometry. So your fundamentals should be strong enough so that while solving a real world problem, this might come in handy for you, right? So another thing that most of you need to remember is this: don't get petrified upon looking at this table. So this is just simple. So we will discuss how these values have come, right? So it is nothing but, so you have this triangle, and how do you obtain these values? You let this hypotenuse project over adjacent. What happens is, when this moves over this side would disappear. So this would be 0, and this two would be equal. So in the same way, if you do for several things, you would arrive at these kind of values. So you have sine 0 is 0, cosine 30 is half, sine 45 is root 2 over 2, it is root 3 over 290. You can even have up to 180, 270, or 360, whatever it is. But these are going to repeat like that. Okay. So I hope this session is quite useful for you, and maybe you can try this out on your own. So we will meet some other time, right? Thank you.